Okay, so in this video, I'm going to teach you how to find the inverse of a simple rational function and use this inverse in finding the range of the given function. Suppose we have, say, a function f of x is equal to 2x plus 1 over x minus 2. Now, if we want to find the domain of this function, then that's simply x such that x is an element of the set of real numbers. However, x cannot be equal to 2. The reason is that when x is equal to 2, the denominator becomes 0 and the function becomes undefined. So we have to restrict the domain, and that is x cannot be equal to 2. Now what if we want to find the range? For some functions, finding the range is not too obvious as finding the domain. Like in this case, we can already tell that x cannot be equal to 2 because it's very obvious that 2 will make the denominator equal to 0. So we'll use a technique, we will introduce another idea which will help us find the range of the given function, and that is by finding its inverse. So for now, we'll leave that portion of finding the range and focus first on how do we find the inverse of a given function, and how will that help us to find the range of the given function. Okay, so let's use the same function f of x is equal to 2x plus 1 over x minus 2. In finding the inverse of the function, first we rename the f of x as y for us to easily manipulate the equation. So we change f of x to y, and then we have 2x plus 1 over x minus 2. And from here, you interchange the x and y. Literally interchange the x and y. So that means the y becomes an x, and the x becomes the y. So 2x becomes 2y. Then you have the plus 1, retain the plus 1. The x below will become y, and then retain the 2, or minus 2. And once you interchange the x and y, your next step is aim to solve for y from the given or from the resulting expression or equation. Okay, so our goal now here is to find the y. So if we continue to work on this and find the y, what you could do is multiply both sides by y minus 2, and this becomes x times y minus 2 equals 2y plus 1. Note that y minus 2 will cancel with y minus 2. And then distribute, you have xy, so that's xy minus 2x is equal to 2y plus 1. So my advice, this is xy. So my advice, when you are manipulating the equation, make sure that you know the goal. The goal here is to find the y. And in this step, you could see that there's an xy and there's a 2y. When you solve for a variable in a given equation, you need to isolate the variable, and that means you have to place all the terms containing that variable in the same side. So that means if I have xy, so I have xy here, then this 2y should be in the other side. And if we subtract 2y on both sides, then you have minus 2y here, and then you have equals 1, and then this minus 2x should be on the other side, so you can add 2x on both sides, and you can have 1 plus 2x. Okay, so I'll just make that clear because I made it direct, like 2y on the other side and 2x on the other side. So what happened here is that as we subtracted 2y on both sides, we also added 2x on both sides. And if we will be simplifying each side, we will end up with this equation. Okay, so once all the variables, or all the terms rather, that contain the variable that we want is on the same side, so try to find a way that you can create a single y, meaning to say, because what you have here is an xy minus 2y, you need to extract the y. To extract the y from two expressions, then what you can do is to factor out the y, and you can have x minus 2, which is equal to 1 plus 2x. Okay, so and then you have, so solving for y is equal to 1 plus 2x over x minus 2. And this is, once you have the y, this is now your inverse. Okay, and the symbol for inverse is like the f of x with a negative 1 floating here to symbolize that it's an inverse. Then we simply copy 1 plus 2x over x minus 2. Now we have an interesting function. We have selected, actually, if you look at the given function, it's 2x plus 1 over x minus 2. And the inverse is 1 plus 2x over x minus 2. They are the same. Okay, but we don't say that that's always the case. It's just so happened that when we work on the inverse, we ended up with the same expression. It's not always. Okay, now this inverse will help us now find the range of the given function. Now here's the key. Here is how the domain and range of the function and the inverse are related. So take note of this relationship. Say this is f of x and this is f inverse. Okay, the inverse of f. The domain of the function could give us an idea on what is the range of the inverse. The range of the function can be taken or be guided by the domain of the inverse. So earlier in our problem, we wanted to find the range of the given function. And again, we said it's not too obvious. So what we did is that we look for the inverse, and hopefully that inverse could help us. And this is the key. Once you have the inverse, identify the domain of that inverse, and that will guide you in finding the range. Okay, so if we focus on our resulting inverse. This is the expression for the inverse, and the domain of this inverse is x also cannot be equal to 2. X cannot be equal to 2. So how do you translate that to the range of the given function? If the domain of the inverse is x cannot be equal to 2, then the range of the function, the range is y. Y cannot be equal to that same number 2. So the same values. Okay, just take note that when we speak of domain, we are talking about x, and we speak of the range, we're talking about y. So don't just copy x cannot be equal to 2 because the range is y. But the thing is, that number that you see here are also the restriction, okay, or is the restriction of the range of the function. So in the same manner, if we want to find the range of the inverse, we don't analyze the inverse, but rather we just refer to the domain of the function. Earlier we said x cannot be equal to 2, therefore the range of the inverse is y cannot be equal to 2. Okay, so I will end this video by asking you to work on a similar problem and try the steps. If you forget some steps, then you can just go back, rewind the video, or go to a specific time. Okay, so try this out. Suppose, so I'll label this as an exercise. So suppose you have f of x is equal to 3x minus 4 over 2x plus 3. Okay, so keep in mind, in our example, we ended up with the same expression. That's not always the case. Okay, so you don't expect that the inverse of this is also 3x minus 4 over 2x plus 3, although there's a possibility. Okay, but I need you to perform all the steps and see, okay, what will be the inverse. So in addition, I need you to indicate, just for practice, what is the domain of this function and what is the range of this function. As you solve for the domain and the range, you'll also be able to find the domain and the range of the inverse. So you learn two things in one problem. Okay? So again, let us summarize what we had. This was about finding the inverse of a given function, and we learn a way, and that is to find the inverse of the given function that will aid us or help us to find the range of the given function. And there are just some important steps that you have to perform. So first is by renaming f of x by y, and then you interchange the x and the y, and then solve the equation for the variable y. That y, so once you perform all the steps and end up with a y, that will serve as your inverse. The inverse can be used to find the range of a given function by noting this relationship. Okay, so again, as we said, I've said, is the inverse in this function is actually the same with the function, but it's not always the case. Okay, so I hope you were able to understand the concept of finding the inverse and how to use it to find the range of a given function. That's it.